Okay, example 4 for 6.1, verify the identity cosecant squared minus cosine squared cosecant squared equals 1. And looking at the two sides that we have to choose from, we have the left-hand side, which is all this stuff, equals to the right-hand side, which is 1. And what I told you on Monday was we look for the one that has more stuff you can do to it. So which one's uglier, basically, and meaning the blue highlight looks a lot uglier than the yellow highlight, right? The one's pretty simple, where the rest of it's pretty complicated looking. So as far as making a decision which side should I work with, I would pick the left-hand side in this case. So first thing I would write on my paper would be the left-hand side, cosecant squared x minus cosine squared x cosecant squared x, which is the left-hand side. Then, my goal is to make it 1. So one thing that I consider when I'm doing these is how many terms do I have over here, how many terms do I want it to be. So the fact that I have 2 terms and I want it to be 1 term, that's going to be an issue for me. It's the fact that I've got too many terms on the left-hand side. The other thing I want to consider is when I start seeing trig functions squared, I'm thinking Pythagorean identities initially. But even before that, term 1, term 2, I'm looking for common factors. Is there some way I can pull a common factor out of that? So I see that cosecant squared of x is common. And cosecant squared taken out of cosecant squared is going to be 1. And cosecant squared taken out of cosine squared is cosine squared. And that's just factor the greatest common factor. As a general rule, if I have the ability to separate trig functions away from each other, in other words, there's different kinds of trig functions here. By pulling this out, I've got one factor containing one type of trig function, another factor containing another type of trig function. That's usually a useful thing to do to get those separated. Right, so each factor contains a trig function of its own. Now, looking at the Pythagorean identity situation here, 1 minus cosine squared of x is equal to sine squared of x. That's a very useful substitution there because I'm going from 2 objects into 1 object, and we're trying to make 1 object, right? So anytime if you're trying to make a single object, you can change 2 into 1. That's a useful thing to do. That's number 6, I believe, right? Okay, in addition, I can see cosecant squared. Cosecant, according to number 4, cosecant of x is equal to 1 over sine of x, right? Mm-hmm. For that matter, cosecant any power of x is 1 over sine of that power of x. So if you see cosecant squared, it's 1 over sine squared. Cosecant to the 5th is 1 over sine to the 5th. So if there's a power involved, you're allowed to do that. So cosecant squared is the same as 1 over sine squared. And that's number 4. You're allowed to make more than one substitution in a step if you wish. I can do both of those at the same time. And then looking at the 2 things, we're multiplying 1 over sine squared being multiplied by sine squared. That's just a reciprocal times its original expression, right? So that equals 1. And there we go, have it. So left-hand side, through some factoring, some substitution, simplification, gets us down to the right-hand side. So our identity has been verified. The reason we want to go from the more complicated to the less complicated is to go from here to here, I would have had to just imagine like, well, I suppose 1 happens to equal this times its reciprocal, and by the way, I'm going to use sine squared of x. Okay, it's not one of those things that you're just going to pop in your head like, I'm just going to automatically, I'm just put this in this. I could have put 7 and 1/7 also, but that's not going to help me get to where I'm going. So, it's much easier to go break something down than it is to build something up. So always, you start with a more complicated side, there's more options on how to do it. So I recommend that highly.